To wrap up this lesson on data abstraction, let me show you the 4 kinds of data abstraction. So it's along 2 axes. So we have the state axis, whether or not the abstraction uses cells or not, and another axis which I call bundling, whether or not the abstraction combines values and operations together, like in objects, or keeps them separate, like in abstract data types. So this gives 4 possible ways of doing data abstraction in all. In most modern programming languages, only 2 of these 4 possibilities are used in general. So there's the objects, which contain state and which are bundled, and then there's the abstract data type, which have no state, they're constants, and they're not bundled. But there are 2 other possibilities, which are the stateful abstract data type containing cells and the functional object. So stateful abstract data types are fairly rare, but they're still used. Functional objects are in fact extremely rare. So let me explain a little bit these 2 less used data abstractions. So first of all, the functional object. So how does this compare to a standard object? Well, a functional object is immutable. It contains no state, it's a constant. If you invoke an object, then instead of changing the value, the state of the object inside, it returns a new object containing the new value and the same operation. So the original object is not changed. This is, in fact, extremely rare in modern programming languages. The second new kind of data abstraction that's less used is a stateful abstract data type. In fact, these were much used in the C language. In the C language, which is a precursor of C++. It's less used nowadays, but it used to be in the 1970s, and up until fairly recently it was still used. Now it's mostly supplanted by C++. So in C, these were quite often used because C did not have objects. Unfortunately, C does not have enforced encapsulation, so that the use of these in C depended on the programmer's goodwill and not looking inside them. They're also used in other languages. For example, in Java, we can have classes with static attributes, and since classes are a form of abstract data type, this gives us a stateful abstract data type. Let's take a closer look at them, because in fact stateful abstract data types are fairly interesting. So here's our trusty stack, which we've already implemented as an abstract data type and as an object. Here is the stack implemented as a stateful abstract data type. Now this is interesting. Let me explain it to you. This uses both a cell and a secure wrapper. Notice when we do a new stack, we first create a cell with nil, and then we wrap it. So we have, in fact, a securely wrapped cell, a securely wrapped stateful thing. Now, if we do an operation, for example, a push, what we will do is we will call unwrap to get access to the cell, and then we will do an operation on the cell. But we will not use wrap. Notice that push, pop, and is empty do not need wrap. They only need unwrap to look at the cell that's inside, and only new stack uses wrap. So you see, it's actually quite different from the usual abstract data type. Let me now conclude the lesson on data abstractions. So first of all, they are a key concept. Okay, if you want to build large programs with confidence that they are working correctly and in large size with teams, then you need data abstractions. They are built on language concepts, in particular higher order programming, static scoping, explicit state records, and an encapsulation concept called the secret key. This is called a name in Oz, which I will not explain further in this course, but it's also an important concept. We have defined precisely the data abstractions in terms of these concepts. The programs we give that define them are in fact giving the semantics. Since we have given the semantics of procedures and of other operations in the kernel language, our definitions are giving in fact the semantics, precise semantics of data abstractions. So with this lesson, you know the precise semantics of data abstraction. Another point is that there are 4 kinds of data abstraction along 2 axes. So there's the object versus abstract data type on one axis, and stateful versus stateless, whether or not they use cells, on the other axis. Two of these kinds are much more visibly used than the others, but their others are also used, especially the stateful abstract data type. In fact, functional objects are almost never used. If you find a use of those, please let me know, because I would be very interested in knowing that. A final point is that modern programming languages strongly support data abstractions, much more than just objects. They're called object-oriented programming language, but that's only focusing on one part of the data abstraction. They would be better called data abstraction languages and not object-oriented languages.